Okay, guys, so we're going to go through this. We're going to do these by elimination. 2x minus 7y is equal to 11. And I'm going to write this other one up top. Negative x 5y is equal to negative 7. I'm just doing that to save myself some time of writing. I don't want to write 2x minus 7 again. So I'm going to multiply this top one by 2 because I want to eliminate x because that's the easier one of the two because this is 5 and 7 and that's not going to be nice. So 2 times negative 1 is negative 2x. 2 times 5 is 10y. 2 times negative 7 is negative 14. So now when I go to do this, 2 minus 2 is 0. This is 3y. Negative 3. So y is negative 1. So if I plug that in, I have 2x minus 7 times negative 1 is equal to 11. This is 2x plus 7 is equal to 11. Minus 7. 2x is equal to 4. X is equal to 2. So we have 2, negative 1 as our first solution. For the next one, we have 3x minus 4y is equal to negative 1, and 17x minus 2y is equal to 15. Okay, so if we're going to do this one, I'm going to multiply to get rid of y because 2 and 4 go into each other. I'm going to multiply by negative 2 in this case. This is negative 34x plus 4y. I just want the opposite, is equal to negative 30. This is negative 31x is equal to negative 31. X is equal to 1. We plug that in, 3x, 3 times 1 minus 4 times y is negative 1. So 3 minus 4y is equal to negative 1. And we minus 3, negative 4y is equal to negative 4. Y is equal to 1. So we get 1, 1. And that is that. So for the next ones, these ones are kind of quick. We just multiply diagonally and subtract. So we go 1 times 3 minus 7 times 4. Yes, you do have to do it in this order. Top left to bottom right and then backwards. This is going to be 3 minus 28. Negative 25. For the next one, we have to write the columns 1 and 2 next to this. So I'm going to rewrite it down here to make sure it's close so you can see it. So we've got I've just rewritten columns 1 and 2, and then we multiplied diagonally. This is 3 times 2, that's 6 times 1. Then 1 times 0 times negative 2, that's plus 0. And then 1 times negative 6 times negative 4, negative 24. Minus, okay, I'm going to do this next part in red. Negative 6 times 1 is negative 6. Plus 2 times 0, oh, we got a 0, 0. 3 times 2 times negative 2 plus negative 6. Okay. So this is going to be 6 plus 6 minus 24 minus negative 12, which is going to be 6 minus 24 plus 12, which is 6 minus 12. Yeah, 6 minus 12, which is negative 6. So your answer for that one is negative 6. And then we have 3 to the negative 2x plus 1 is equal to 81. So we're just going to rewrite 81 as the power of 3. So we have 3 to the negative 2x plus 1 is equal to 3 to the 4th, which means negative 2x plus 1 is equal to 4. Negative 2x is equal to 3. Divided by negative 2, we have x is equal to negative 3 halves. Since the domain of exponentials is defined over the entire x range, then we are good to go. And then finally, we have log base 3 of x minus 2, log 3 x plus 1 is equal to 4. So this is log 3 of x minus 2, x plus 1 is equal to 4. So we treat these like powers and raise these to the powers. So this is going to be x minus 2 over x plus 1 is equal to 3 to the 4th power, which means x minus 2 is equal to 81 times x plus 1. And so this is going to equal x minus 2 is equal to 81x plus 81, add the 2, minus the 81. Negative 80x is equal to 83. Divide by negative 80. Oops, that's gross. What is that? And we get x is equal to negative 83 over 80. Well, if we plug that back in, we do have to do this. We do have to plug this into the original. If it is negative on these two, then we have an issue because it turns out that the log 3 of negative 3/80 is not a real number when you plug it into this one, and it won't be real for the other one either. And so the answer here ends up being no solution. So just check, guys, if you get a negative inside of a logarithm, you can't do it. If you get it for an exponential, that's fine, but for a logarithm, we have an issue. So make sure you check it. Thank you guys for watching.